Up is Rahul from Foundry. Rahul Veer is one of the product managers in Foundry Networks. He's responsible for product development and evangelizing technology, allegedly. Do you need a hand with the laptop? Run over a little bit, say 20 minutes. Can you do it in 20 minutes? Yeah, that's great. Yeah, if you just want to shoot through again. And Rahul said he's going to try and get us back on time, sort of get this in 20 minutes, sort of 25 minutes. And don't forget, we've got the big announcement of the SC election results coming up after this. Rahul.
Thank you. Hi, I'm Rahul Veer, and to give a little bit of background on the topic, as providers move towards a converged network for their residential triple play as well as business services, the challenge is how to have a monitoring solution that can deliver service quality and security in those networks. And I'll be discussing one method of doing that, and then look at a few use cases and how to achieve those. So I was intending on covering the whole voice, video, data, as well as business services, and then give a traffic management example. Depending on the time, I'll probably skip that example, and you can look up the slides, and if you have any questions, you can send me email. So to start with, as I mentioned, the converged networks basically bring in the challenge of a lot of services that require different kind of guarantees, and the services could be voice, video, data, or layer 2 or layer 3 VPNs. Now, we can come up with targeted solutions for each and every one of them, but the whole thing becomes so unwieldy that it's not a practical approach. So we want to come up with a solution that's a single solution and does not destabilize the network in any way. So it's basically transparent to the service that's being delivered, as well as it's standards based and doesn't get into any vendor lock-in issues. So the solution is basically using technologies like S-Flow and NetFlow. Now, I'm assuming most of you are familiar with S-Flow, but basically to give a brief overview of that is that S-Flow is a technology that's a monitoring technology where packets with the traffic is actually sampled, and the sampled traffic is sent back to a S-Flow collector at a different location where it's used for offline analysis. So most of the sampling actually does happen in the hardware, which means that it doesn't affect the management processor and doesn't impact the network as far as it's delivering the services is concerned. And all the analysis is actually done offline, which means that the router as such is not affected. So the proactive monitoring solution using S-Flow, it enables predicting, detecting, and isolating any potential problems that could be there in the network. So let's start with the video networks. So this is a typical video network where you have the video head end on one side, and you have a network in which the edge routers, the services are being delivered to the customers through the edge routers. Now, in this particular solution, we've enabled S-Flow at various points in the network, and the S-Flow data is sent back to the collectors, which is located at the NOC over here, and that's could either be going in band or out of band. Now, depending on the network. Now, the routers need to be S-Flow enabled. If some of the routers are not S-Flow enabled, we can take a passive optical tap and send it to a S-Flow enabled router. So in this particular solution, what we can do is we can take the stream whenever we see a certain trigger. Now the trigger could be either we've missed a few S-Flow samples, or we have the operator actually wants to look at the stream, or a customer has called in and said, okay, I'm not receiving my video properly, could you check that? And with these triggers, what the operator could do is put an ACL based mirror on the point where the problem is observed, and take that traffic and send it back using a VLL to the NOC, and then you have the original stream and the stream that is going to the customer, and side by side you can compare that. So this provides a closed loop network visibility. The sampling rate on this could be as aggressive as 1 in 512 packets. Usually it's kept a bit higher depending on the rate of basically the speed of the interface. So let's go on to the next slide. This one basically shows a flow chart of what happens. You program SFlow at various endpoints on the routers, and the samples are sent to the SFlow collector in the NOC. One of the 3 triggers that we described, the moment that's done, with those triggers we'll program an ACL that will mirror the traffic back, and then we can compare that to the original stream and take recovery action. So after that I said, okay, let's see what's the overhead that's coming on the network. So I took the most aggressive sampling rate, 1 in 512 for SFlow, and then took a 10 gig interface, added all the overheads that's there in the SFlow packets, and put them together, and saw that the overhead on that interface was about 0.02% of the interface rate, which is very low overhead. So that's good. So to sum it up for video networks, basically this provides us a real-time network visibility solution without any performance degradation, because all the SFlow sampling is happening in the hardware, and the SFlow collector is also doing the analysis is being done offline. This one easily integrates into existing infrastructure. All that needs to be done is enable SFlow on the various points in the network, and depending on how much load you can tolerate in the network, you can increase or decrease the SFlow sampling size. Also the infrastructure can also be made very reliable. The way to make it more reliable is provide in-band and out-of-band way of sending SFlow messages. Provide multiple SFlow collectors, and that can also be done. The video stream that's going back after mirroring is going over a MPLS VLL, which is using the underlying MPLS infrastructure. That provides the resiliency of MPLS. And you can have multiple locations. Actually, you can put the mirror traffic as well as SFlow at a different location if desired. Doesn't have to be at the NOC. So going on to the next this thing, using MPLS VPNs. So in a MPLS VPN network, so more and more business services are moving towards MPLS-based VPNs. It could be layer 2 or layer 3 VPNs. But the challenge out here is that the customer traffic is all aggregated together into a single tunnel, and any aggregated statistics that can be taken out from the tunnel are not very useful. So the requirement out here is to find out the ability to monitor traffic performance and availability, but get information on a per VPN endpoint basis. So so you want information on a per customer basis on the top talkers, the traffic trends, and any threat detection, but not aggregate, but on a per VPN instance basis. So this needs very similar requirements as the previous network. You need to enable SFlow at the provider edge networks, provider edge, and then take that to the SFlow collector that can be at the NOC. And then you can use standalone SFlow collection that supports MPLS traffic analysis, and there are a lot of them available from various vendors. The SFlow version 5 includes MPLS-based information, and in the MPLS-based information it has so MPLS VC information, which is basically the VPN instance information. So it has the VC name, VC ID, and the cost value. As far as tunnel information is concerned, it can have tunnel name, tunnel index, and tunnel cost as well. So any abnormal traffic patterns that can be detected over here, we can look at that and take actions accordingly. So I have a few examples in the subsequent slides which look at traffic trends per VCID, top talkers, and traffic totals based upon various parameters that are there. So here on the left side, I have basically two VPNs, two VPLS instances, so two different customers, VPLS 421 and 422, and the graph actually shows what the traffic rates are, bits per second, for the various customers. On the right side, you can look at the chart. How this chart is more useful when you have a bigger number of customers. Let's say you have 10 customers and you're looking at there is a certain trend among most of the customers, but you see certain outliers, like someone's taking way more bandwidth. Then you can take action like migrating them, asking them to migrate to a higher bandwidth, a higher price service, or rate limiting them. Here's some tables that has more information about the packets. In the lower table, if you look at it, it has information on the VPLS instance over here, as well as the traffic type. So that's the ether type in this particular case, the MAC source and the MAC destination, and what's the total bandwidth that this particular customer has used, and based upon this source and destination as well. So you can get that level of detail on that information. So since this is a sampling based approach, there is an error range because the total traffic is based upon sampling, and in this particular example we can see that we can reduce the errors, but to reduce the error we have to do one of the two things, or both. One way is to increase the sampling rate, but that increases the overhead on the network because you're sending packets to the collector more often, or take the samples, or increase the period over which the samples are collected, which is not actually any additional overhead. So that way you can reduce the error in that. If you need more details, there's a link over here that has more details on how these are calculated. So benefits of using S-Flow in an MPLS network is that it's very low overhead. All the collection is done in the hardware. The analysis is done offline, and it provides you real-time monitoring. So you can monitor the SLAs of your high-level customers, as well as identify top talkers and then take action accordingly. All the time providing full visibility of the network, as well as reporting as well. So that's for the MPLS networks. So regarding other services, which include, so if you are triple play, you've left out voice and data services. So the way to, one way to look at that would be based upon the service class. So a lot of carriers, when they're sending out, when they're using voice traffic as well as mission critical data as well as and best effort data, they all sent over different priorities. So you can use IPv4 toss field or IPv6 priority fields to identify those streams, and then traffic patterns can be studied accordingly. For voice traffic, it's a bit more complicated. The one way to do at a very high level, you can get some macroscopic information by looking at by analyzing the RTCP traffic, and you can get some high level metrics and get some quality of service trends in the whole network. But that's very high level. Other ways of doing is you can filter the RTP traffic based upon codec and the source destination IP, and you can get information like overall packet loss, jitter information, and use that for voice quality. For high-speed internet access, there are multiple uses of actually they can provide good information. First one is for trending, where you want to see where the traffic is going, and you can actually project it in future and see what are the expectations of the network and how fast it's growing and what you need to upgrade to at a future date. Also, it can identify popular sources, be it Google or Yahoo or YouTube or Xbox Live. All that information helps in optimizing the network. Now you can, based upon this information, you can reduce the congestion in the network, latency, or optimize reduce the transit costs. Same thing, you can also look at the AS path information and for the traffic, and then reduce transit costs by getting a direct peering relationship in case the traffic's a lot. So various traffic analysis tools are available for this, and I mean various vendors do that. There are freeware tools as well, and all this analysis done offline, of course, and without affecting the performance of the network as such. So how this next item is how we can use this approach for enhancing security in a network. So one approach is ACL based inbound S-flow. What this does is you can actually configure an ACL. If you're expecting a certain kind of traffic, you can configure an ACL, and only those packets that match the ACL will be sent to the S-flow collector. This is useful for things like any reconnaissance attacks or DOS attacks or any network misuse. The example out here is showing a particular host basically capturing all the TCP SYN packets, and that can be monitored offline. The advantage of this versus mirroring is that it's lower overhead because it's going to get only the packets that match, as well as it's only taking the header of the packets, like 128 bytes, rather than sending the whole packet. So that makes it much more usable. So here are the two examples. The left side is for threat detection when it's a known threat, and the right side is a new threat. So looking at known threats, we know the signature. Let's say it's a worm. We know the signature of the worm, and we can look at that particular signature, and you can perform offline analysis by comparing that to the known signature. So the moment that is detected, it can trigger an alarm. On the other hand, when it's a new threat, we are not aware of any signature because it's a new threat. At that time, we're looking at profiling. We should start profiling the behavior of hosts. So if certain host is actually scanning all the ports, in that particular case, or there are policy violations, we can detect that and then take recovery action. So in both cases, the recovery action could be either applying a rate limiting ACL or using drop policies, or also the other way is to use BGP blackholing. So I have a traffic management example. I'll quickly go over one slide. Basically, the thing out here is some of the users, the problem statement is that some of the users in the network are actually using most of the bandwidth, and the network capacity is limited, which means that we want to use the network we want to optimize the traffic management in the network. So to do that, the traffic that's coming from the host is we're using traffic management, basically measurements using S-flow or NetFlow, and then we can use controls to actually mark that traffic either down by priority, or we can rate limit it or block that traffic. So whenever the traffic's marked with a lower priority, it will go to the router, and the router will give better preference to the traffic that's conforming versus that's not conforming. So I don't want to spend too much time on this one because of time constraints, but so basically summarizing that we can achieve good service assurance using proactive monitoring. Now what this provides us is that it's a real-time S-flow based monitoring solution with very low overhead on the network and hardware, and all the analysis is done offline. So you can do much more offline analysis, and at the MPLS level you can get good information about MPLS VPNs, and it provides a good tool for effective anomaly detection and recovery mechanisms. So this time, if you have any questions, I'll answer those.
Okay, if
Okay.
there are no questions, thank you very much,
Thank you.
Rahul. And Betty, are you ready to